Today we are going to give you some guidance how to design an embedded systems and write your first programs. So let's see what we need. First, I would like to introduce a visual programming tool designed by UC Berkeley called Snaps. So Snap is very easy to use, and Snap is based on MIT's Scratch. However, they provide more programming functionality like first-class object, first-class list, and first-class procedure, and a bunch of things which Scratch cannot do. So I guess this is better programming tool to teach students what's programming and how to solve problems. And as you can see here, Snap actually divides by 5 categories. So on top of it is a menu bar, and here we have a file menu. This guy is file menu, and this is cloud. Something related to cloud, you can use this one. And this is the option, and this relate to a stage. A stage is an area the sprites can show up. What does it mean? You can have a bunch of sprites. A sprite means programming elements. They can have different kinds of. Here we have different costume, and you can write different programs. And also you have some sound or musics. You can work on these sprites. So some result will be displayed in this stage area. So this part is called control panel, or some blocks. That means in all the programs, basic programming block actually are shown here, and they are 8 categories, which is motion, mean you can move sprite, and looks mean you can change the outfits of the sprite. And songs mean you can write some songs or music, so that when the sprite move, and they come with the music. And the pen mean maybe we just go to the panel and we can see what is. So if we go to maybe it will crash. I think maybe. Yeah, as I mentioned that if I try to record something, then the Chrome actually does not work very well. So okay, so I have to use offline version. So we have offline version. So here we can see that we have up here they are, what shall I say, these are snap blocks. So the motion, you can turn the sprite, move sprite 10 pixels, and you can turn the sprite as well. So you can see you can turn, and you can also move and turn, something like that. Okay. And the look is the outfits of the sprites. For example, you can go to the custom, and then you can say I want to change the custom of the sprite, so that we can have bunch of the thing you can choose. So for example, we choose Alonso, and you may suppose you want to have motion picture, and probably you can add more costume, and then you can change the costume, and it looks like moving. So the movement, you can also do this, but we are not focusing on writing Snap, so I'm not going to try this one. And songs mean you can play, you can import song here and then play songs, or you can play some tones. So you have to go back to the scripts, and then you say you want to play tones, and there will be some songs. So as you move, you can play song as well. And the pen is when you move, then do you want to leave a trace or not? So if I go back to these costumes, and if I put the pen down, So I have to go back to scripts. If I put the pen down and I just click one, and maybe I can also change the color. Maybe I like to have a blue color, and then this will change to blue. And when I move, sorry, pen up. Sorry, I do something wrong. Should be pen down. Okay, not pen up. Okay, so when I move, and I also leave a trace. And so it's very easy because when you do programming, and you also see the result immediately in the stage area. So that's very good tool. And the control is some kinds of loop and branch, or some other control command you can use. Sense mean if some sprite touch another sprite or hit another sprite, and you can maybe say, okay, you out of the road. You be the racing car, then you out of road. Or maybe two friends, they meet each other, and you will say hi, or and they can start dialogue or whatever. So this is some kind of when you write in games, you might want to do some sensing. And operator mean they provide the arithmetics and logic function for you. So they provide a bunch of some kind of operations for you to use. And the last one for Snap is called variable. You can store in either one variable, or you can store a bunch of things in list, which is very important data structure here. So these 8 categories provide different kinds of blocks for you to write programs. So our first step is we try to give you very simple example how to use this block, and then we will move to embedded system and IoT system designs. We will use these 6 block here. 8 block here. So let's go back to the lectures. So as we can see that we have a scripts here, so that you can drag and drop program to the working area, like I just did, right? So we can say maybe draw some clear here. You can snap it if they have a bar here, and then snap it. So I can just do something like this, and then I put a pen up. So when I move, they shouldn't have draw something. They won't draw anything at all. But if I say pen down, then when I move, I do leave a trace. So you just drag and drop your program, and maybe if you like to snap it, then they will first execute this blocks and then this block. So it's like a statement, sequential statement. You can snap this sequential statement together. Okay. So and here is called working area, and in the working area they have 3 tabs. One is script, as we can see here. One is scripts, so that you can put program in this area, and the other is custom. You can change the sprite outfits, and then the last one is sounds. When you try to import some special, maybe a dog or maybe a cat sounds into here, and then when they move, they could have these sounds, play these sounds. And so this is working area. And also we have sprite area here. The sprite area here, actually you can create more sprite. Say for example, if I'm here, I can create another sprite. So if in this sprite, then I have my own program, and this sprite you can put another program here, and also you can have different outfit as well. So if you want to write in games, then you must need a lot of sprites working together, something like this. Alright, I guess good enough introduction to the Snap. That probably we can try to write a simple programs. As we mentioned that they have 8 category of blocks. Motion means moving the sprite, and looks mean you want to change the outfit of the sprite. Sound mean you can play song or music, and as the games go on. And the pen mean you probably want to do some geographical figure, so that you can put a pen down, you change color and change width, and then you can do a bunch of drawing stuff. And the control mean you want to say if something happened to this and some other thing happened to that, or maybe you want to say, okay, draw 4 times to make 4 size regular rectangle, which is called square, right? And maybe you can draw n size regular polygon. We would do this as our example. And also you can do some sensing, because you have so many sprites on the screens. So one sprite touch the other, and then they can do some sense and do the arithmetic and logic operations in operator. And you can create a single variable, or create a data structure called list. So okay, let's try to write our own programs. Here we try to write some kinds of regular polygons. So we understand triangle and square when we are in primary school, right? So drawing triangle and square should not be a problem. But do you have seen 7 size polygons? Do they exist or not? Or if they exist, can we draw it? It's called heptagon. And how about 17 size polygon? Do they exist or not?
Yes.
They do exist? Okay, so do you ever saw one? 7 size polygon? No,
yeah,
right?
Maybe.
You maybe saw it, but you forget it, right? So okay, we can just say if it exists. So can we, write a program? They can draw n size regular polygons. If we put n equal to 7, then this should be draw the choice for us, right? So the way to do it is actually just like when you learn computer, you maybe first you draw a square, and then you maybe draw triangles and see some kinds of rules there, and then you come up with the how to draw n size regular polygon, right? So maybe and you can say that make a new block, right? We make a new block and with parameters n, and which is equal to functions, as you learn in your programming language, right? So in here actually we use block to came up with functions, and in the function you can have parameter n, and n actually is a number, right? N could be larger than 3 integer. So how are we going to do it? So maybe we can work this together. So in this case, we will create a project first. So we just give up the old drawing, and then we don't need the project for Snap. You don't really do anything, but when we try to write our embedded system, we need to new no MCU project, but we will do this later anyhow. So then I think what we can do is we try some move, right? Move maybe 10,000 steps. And for the square, probably just turn 90 degrees, right? And if I want to see how it's going on, I just click and to execute it. So I just click the first one, the second one, the third one, and the last one. So you can see that actually it looks working. However, you don't draw anything, right? So then we go to the pen category. And then, as we mentioned, you put the pen down, right? Put the pen down. And maybe you can change color. Instead of black, you use, as I mentioned, maybe you like a green one, okay? And then you want to execute it, just click this again. So you can see that the sprites become green, right? So that now we can do it again. So we leave a trace. Do the first time, the second time, the third time, and the last times. So you draw rectangles. So you would know that probably not a programming, right? Because you click 4 times, but can you just click 1 time and draw the regular polygons? So okay, so we go to control here. So when you have control, you scroll a little bit here. That has repeats, right? Repeats. So if you do something like this, and they will just include 1, but you move up a little bit, then you repeat this 10 times. But you need only 4 times, right? Instead of 10. So you repeat 4 times. Or the other way is you just drag and drop the repeat block and move it inside it. And then you probably need clean up a little bit, so you do a clear. You clear the whole things, and then you run it. So in this way, you write a program who can draw a square, right? So do you have any problem, Jonathan? No. No. Okay. So okay, and then I will teach you how to do the duplication. So go here, and then click right side, and we have duplicates. So we just duplicate this block here. And let's try a triangle. So the triangle should repeat 3 times, right? Instead of 4. And also, what degree we should turn? 120. Yes, 120 or maybe 60, right? Let's try 120. So we try again. So we do draw a triangle. So what did you see? The rule to come up. Suppose this is the unsized regular polygon. So what the degree change? Do they have some kinds of rule? You can see.
Yeah. So you can see 360
divided by
the number of the size.
Okay, great. So right now you understand the rule, right? So in this area, you can click a mega block. Mega block mean create a function, and then you have to say this block actually in which category you want to put inside. And this is draw, right? So it's similar to pen. You want to draw something, and then you say draw maybe some regular polygon. Okay, and you click OK. So first you choose which category. Like this, I would like to put a block inside the pen category, and I click OK. So there is no program block at the moment, and I choose OK. So I just draw down a little bit. You can see that I have draw regular polygon already, right? But there is no parameter, right? So it's not a good one. So you can go here and do right click and do edit. So here we try to use the size, draw unsized regular polygon. So in this plus sign here we do a click, and then you can add your parameters. So maybe just say n, right? Draw n size. And we also have a button here. It means some kinds of option you want to add. So you can click this one, and it belongs to number. So we click number, okay, and then OK. So right now you have parameter at the moment, right? So if you have parameter, then you can use the same thing. We just duplicate, and then we click duplicates, and then move into the here. Okay, do it again. Must have a white bar, and then you do some click. Okay. So right now you do have parameter here, and you say when you want to draw n-size regular polygon, you have to repeat n times, right? And then you need to turn, as Jonathan say, 360 divided by the size of the polygon. Then you complete your programs. Then you click OK. And as you go back to the pen category, right now it's become have the so if we clear the whole thing again and we say draw three size regular polygon, then they can, so it's correct, right? And we can duplicate again. How about 4 sides? It's correct, right? And maybe you can keep doing this and say, how about 7? And how about maybe 11? And then you can see the drawing is here, right? And maybe you want to move up a little bit, okay? So that you can see more clearly this one. So you can move the sprite in and then do it again. Okay, and maybe we try to use another loop, and we maybe try to draw from triangle to 36 size polygon. So what will we do? We go to the control. Shall we wait a little bit? And you can see that there is no for loop, which we use often, right? No for loop. Actually, in the beginning, they try to teach students more basic block only. If you need more advanced block, you need to go to here and import tools. After you import tools, then you have much more blocks you can use. So, for example, we have a for loop here, actually. Right? So we want to draw maybe from 3 sides through 36. And then we maybe just draw one here, and then put this I parameter to here. And then we can see, maybe we clear this a little bit, and then move this here around. And then you just click this one. And you can draw, from 3 to 36. Okay, maybe I should stop here and then let you finish this homework first. So I just stop recording. So we just finished the some kinds of functions, and the function, as you put parameter inside, like 7, and you can draw heptagons. Okay, so actually computer is really good. You can see something maybe you don't know. For example, if you look into this polygon, what do you see? What do you see? What can you find something maybe you do not understand before? So, and by the way, if you want to draw as soon as possible without knowing how they draw, you probably can go to the option, and there is a turbo mode. So if I click again and I'm in turbo mode, then I can just click this one, and voila, you can see that immediately, instead of they try to draw one regular after another regular polygons. So what do you see? You can see the symmetrics, right? If we draw a line from here to here, you can see that all these regular polygons actually have some kinds of symmetric, right? Even like this is the size of 7, right? I said, so you understand some property which you may not know, before. That's I don't know before, right? So this is the our first program using Snap. So you can see that this tool is kind of powerful, teach you the problem-solving skills. And without knowing much of the programming syntax, you can just drag and drop your programming block. Then you understand how to write the programs. And actually, you can divide and conquer. First, we divide the problem into draw a square, draw a regular rectangle, and you summarize it, and so that you can become a new block with a parameter n. with a new parameter n, and then you can do it. And this tool is very good because they do some kinds of abstraction. They remove some, syntax detail from the user. You don't need to remember the if syntax. You don't have to remember the for syntax. And then you just use it and you can solve the problem. Right? And also, they teach you not just STEMs. STEM in United States called science, technology, engineering, and mathematics. And right now there's a new one called STEAM. STEAM means you also need some, arts. So you need, say for example, you want to design good stuff. You must design from the design view of user. You must be beautiful. You must have some kinds of good artistic, form factor for your products. So I guess this tool is really good, but we don't have much time to say about it since you all don't understand the programs. And if you can draw a square, and how can you make a robot draw a square for you? So this is another challenge. So you give problem to your student, you keep challenging your students, and you keep, make these students, keep interested on what you are talking. We can draw square, later when we go into the embedded system. So I guess you already know how to do it, right? We draw a regular triangle, and this is square, and this is pentagon, and they all exist because American Department of Defense actually the shape is pentagon, right? And we also know how to make a function. This function can be another block, right? When you make a function, it means API. So the original, you have a bunch of API, and then you can create your own API, your own library. So you can, keep adding your libraries so that later you can do things more faster since you have a bunch of library you can use. All right, so if go back to Snap, actually the program just compositing these blocks. You assemble these blocks together, and then it become a program. So it's very easy. But what kinds of blocks they provide? Actually, they provide three kinds of blocks. First, called command block. When you draw something like a jigsaw puzzle block, and they can snap things together, they are command block. It's just equivalent to the statements in programming language. And then you have some kinds of reporter block and predicate block. So for example, in the if-else, we need some predicate, right? It's in programming language, we call it condition. You want to express a condition, but the condition cannot exist by themselves in Snap. So it is kinds of supporting block. They have to, the reporter block and predicate block can only embed it in the command block. In this way, if else statement is a command block, but the condition block need to be embedded. It's a predicate blocks and have to embed inside the if block. And also you might say that for example, reporting block, maybe this is reporting block. You want to add something up and then maybe store somewhere, right? So maybe here we can set some value, and this part can be some kinds of expression. So expression is a reporting block, and they can embed it. When you try to assign some value to assign the result of the reporter block and to a variable, and you can do something like that. So here actually you can put here, right? So this block, reporter block, can report something, and after report something, and we can store in these LED variables. So these are the only three kinds of blocks in Snap. So the concept is quite easy for you to write and to learn the programming language. So, and the second thing is the data type. Data type is very clearly. So, for example, we have numbers. Although it could be integer, it could be real number. In Snap, they just use the oval to represent the any kinds of number. It could be real or it could be just integer. And the second thing is text. Text is represented by long rectangles here. So if the rectangle shape happen here, then you know you have to put some kinds of text. The third one is a list or and some kinds of unlimited arrays, and they have hamburger shape. So actually it's a small rectangle, and inside there's hamburger. Okay, and the last one is any type. The any type it could be, for example, two number you can put it here, or two text you can compare. So mean more than one type mean any type. So use short rectangle to mean any type. Okay. So actually we just do a typing here. Remember we say that the parameter. So we go here, we do some editing. Remember when we say this one, actually a number sign is here. We said maybe you just click this one and you can change the type. So we choose number, right? If we choose text, then what the shape will be different. So today. So let's go back, go see the pen. Maybe I should create another one. So it's like you can see that it become a long rectangle, right? So that we can change it again. So we can say that it's a number, and we can say the default value as well. So maybe we say default is 4. Then click OK, and then OK again. Right now it's become wrong rectangle, or maybe just oval. So they have default value instead of blank. So whatever you learn in programming language, you can apply to this one, and I guess this much easier. So why we do this? Because writing embedded system itself is a difficult job, especially without using this tool. It takes time to it takes time to get used to or can master the embedded systems programming. But you need to know embedded system programming, and then you add some IoT standard and become an IoT application. That's why building IoT application or building embedded system, and in the old way is really difficult. But we make making any IoT application or embedded system much more easier. So by using our tool. So maybe we should continue.